2016 AP Calculus, AB, free response, number 2. Calculator active. For time greater than or equal to 0, a particle moves along the x-axis. They gave you the function that models the velocity, and the particle is at a position that they gave you at a specific time. So you've been given velocity and the specific position at a time. And so first part for number 2, part A, is to find out if the particle is speeding up or slowing down. And I have a little note card here that's going to help us out, and it's this. When's a particle speeding up or slowing down? Well, if velocity and acceleration have the same sign, speeding up, different signs, slowing down. So let's find that out. Given the velocity function is 1 plus 2 sine of t squared over 2. There we go. I want to find the velocity at 4 and the acceleration, which of course is the derivative of velocity at 4. And I have already typed the function in. There it is. Instead of x squared, I typed xx, and whoops, didn't mean to press that. Let's go to the table, press a 4, and I have 2.979. 2.979, and let's be honest, I don't care that it's 2.979. I care that it is positive. I also want to know the derivative. Don't find the derivative by hand in a situation like this. I'm going to press y equals, and I want to go down to y2. I'm going to define a function to be the derivative of y1. Let's press math, and we're going to go to number 8 in deriv. The derivative with respect to x, even though they said t here, I'm using x. So the derivative with respect to x of y1, so alpha trace y1 at any given x value. And now I'll go to the table, and I have a negative derivative of velocity at 4, which is fantastic. So I have negative 1.164, which is indeed, well, negative. And so therefore, my answer is that the particle is slowing down at t equals 4 because velocity and acceleration at 4 have different signs. They did not ask us to justify our answer, but I recommend you do. Because I'm looking at the scoring guide already. Just a conclusion with the reason. So go ahead and say it. Okay, here goes part B. Find all times t, final answer will be t equals something, in this interval from 0 to 3 when the particle changes direction. Okay, but when does a particle change direction or an object? Well, a particle in motion reverses direction when, okay, before I flip this card over, let's think logically. Moving forward, moving backward, moving forward, moving backward. Every time I'm changing directions, then my velocity changes signs. So my velocity changes signs. Now let's think about that logically. Velocity is going to change signs when velocity equals 0 or potentially doesn't exist. So what we're going to do is find everywhere that this equals 0. So let's do it. I need my velocity, which is 1 plus 2 sine of t squared over 2. I need that to equal 0, and I need to do that only on the interval that they said from 0 to 3. So let's do that. All right, so y equals, I don't need this one, don't need acceleration, so I'm going to turn it off. So very sneakily, I went over to the equal sign. I'm going to press enter, and that's it. You don't have to do it sneakily, but I was saying it while I was talking, or doing it while I was talking. So I'm going to press window and go from 0 to 3. Once I've gone from 0 to 3, I'll be able to graph it, see what's going on with this derivative, with this velocity, which is the derivative of displacement. And I'm going to press zoom, and I'm going to go down to 0. You could just press 0, but I wanted to demonstrate it. And doing that means I'm going to adjust the y values based on the x values they gave me. And I am getting this graph here. I'm looking for every x-intercept. And there's one and only one. Okay, so solve it by hand? No thanks, I'm good. Second, in calc, we're going to find a 0. Left bound, well, we are to the left of it. right bound. You can arrow over if you want, or you can go to the right of it. I know that 3 is to the right of it, so I'm just going to press 3. And then for guess, just press enter, and it takes us to it. So 2.7074, da 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 da. So t equals 2.707. I believe that is a good way to round it right there, 3 decimal places. But read the problem carefully. They did say justify your answer, so let's justify the answer. All right, the velocity changes from, now let's look at the graph for a second, from positive to negative. So from positive to negative at t equals 2.707. Therefore, the particle changes directions. At that specific time. Okay, let's do part C. Find the position of the particle. Now I've got to find the position of a particle. Let's see what I can find here. Position of a particle. Oh, here we go. The location of a particle at some time, given its velocity and some other time, some other position at a specific time. Let's try to digest that a little better. They're asking for the location of a particle at a specific time, but what they gave you was its velocity and its position at some different time. So let's kind of deal with that for a second. I'm going to flip that card over. But here's what's going to happen. For part C, I'm going to need, let's just go ahead and jump right into it. I'm going to need the integral of velocity. That's going to give me displacement. So I'm going to build what's happening here without really flipping the card over, and then we'll talk about what's on the back side of the card. So I need the integral of velocity, and this is going to tell me my displacement. Okay, so what are they asking? I want the position of the particle at time t equals 0. Okay, well good. So let's end this sucker at 0. Well, where are we going to start it? Well, where do you want to start it? The only place you can start is at 4, because that's all we know. We know the position of the particle at 4, so we're going to go from 4 to 0. Yes, that is backwards. Should you flip it over and make it negative? If you want to, you don't have to. Totally fine leaving it like this. So starting at 4 and ending at 0, this will tell me my displacement, but I also need to deal with the fact that I had a starting point at 2. Where'd that 2 come from? Here. So I start at 2 and I end somewhere. And it is okay right now, in theoretical terms, that time is traveling backwards. We're going from 4 to 0. I start with a time at 4 and a displacement at 2. I'm in position at 2. And then I will have some displacement from this, and I'll crank out an answer. Just flip a card over. Let's see what happens. Oh, there we go. The position you know, plus your displacement. It works. It's going to work. Even if you're time traveling, moving backwards. So let's do this. I'm going to rearrange it. Let's put the 2 first, then 2 plus math 9, and then from 4 to 0, or 0 to 4 with a negative in the front. And then we need the velocity, which is y1, dx, and we're going to get that. Is it okay that it's negative? Yes, it is. Totally fine that it's negative, and the reason it's okay that it's negative is because they said find the position of the particle, and this thing is on the x-axis. You can be in a negative position. Part D. Find the total distance the particle travels from 0 to 3. Well, total distance that I travel means that I need to take the integral from 0 to 3 of my velocity. And if I stopped right here, then I would really be finding my displacement, because I could move forward, move backward, move forward, move backward, and we'll have lots of positives and negatives. But my total distance traveled would be this. So let's figure that out just to be on the safe side, and this is correct, but total distance traveled, there it is. All right, let's go. Math 9 from 0 to 3. We're going to press math and go over to number, and the top option is absolute value. Put the function, alpha trace, in the bars, and then there's that. Takes it a second. Better get a positive value. 5.301. That's the total distance that the object traveled, the particle traveled on that time frame. All right, let's grade our paper. See what we're dealing with here. Here's the scoring guide. You've already seen it a little bit. I am a little frustrated that they did not say justify your answer, but they do want the conclusion with the reason. So when in doubt, write it out. It rhymes, so it must be true. For part B, we had to set the velocity equal to 0, and we earned a point for that, but we also earned a point for justification. So far we've earned 2 points, one for part A, two for part A, and 2 for part B. We earned a point for that and for the justification. Let's get to part C. This is where you can get a good chunk of points. We had the integral from 0 to 4 v of t dt. We earned a point for that, so earned a point there. But Mr. Reader, what if I put 0 to 4 with a negative? Same thing, you're good, go for it. Did we use the initial condition? Yeah, we did. We used that. Now the scoring guide has x of 4, whereas we just put 2. It is fine, totally fine. And then the final answer got us our 3rd point. And then part D, our integral gave us one of the points that we could earn, and then the final answer gave us one of those points.